Hello, my name is Derek from Tomcat Gas Training and you're about to watch episode 5 of this absolutely amazing, riveting video on the history of central heating. Now if this is the first video you're watching, you're in the wrong place. You're starting in the wrong place. You need to go back to video 1 and start there. But if this is the 5th video you're watching, oh my god, what are you doing? Anyway, let's get on with these boilers. Now the first boiler I want to look at is the boiler what's behind me, which is an open flued floor standing conventional boiler. So let's have a look at that more closely. The reason why we call it an open flued boiler is because it gets its air from combustion from within the room. So this boiler would require ventilation, permanent ventilation provided through an air vent, which would be from outside to inside the room it's installed in. Open fluid appliances require 5 cm squared per kilowatt over 7 kilowatt for ventilation. This is a Potterton boiler. It's a Kingfisher 2, and if you look at the heat input, it's range rateable. Range rateable means you can have different settings and different outputs. Okay, but when we do things like gas rating on appliances, we'll always gas rate the input, not the output. So this is 18 to 23 kilowatt boiler. So down at the bottom here is the combustion chamber, and the gap you can see here is where the air for combustion comes in. This is a sight glass for the pilot flame. Okay, so that's where the air for combustion would come in. There would be a vent, a grill in front of that to allow the air to come in so it mustn't be blocked. When we come up, this is the gas valve. The components of a multifunctional gas valve are the solenoid valve, the regulator, the thermoelectric device. Gas valve, and the gas valve goes down into the burner. The copper coloured cable you can see coming off and around and down into the bottom, that's what we call the thermocouple. A thermocouple is basically a temperature sensing device that is able to generate a small voltage. It can do this because of the Seebeck effect, discovered in 1821 by physicist Thomas Johann Seebeck. He found that 2 dissimilar metals joined together, heated at one end, would create a very small voltage. We call the thermocouple, and the thermocouple is part of the thermoelectric device. This is the isolation gas valve going into the boiler. All boilers require a gas isolation valve. If we go up, this is So this is the flue hood, or what we call the primary flue. Now the boiler flue is in different sections. We have the primary flue, we have the draft diverter, and we have the secondary flue, and at the end of the secondary flue we would have the terminal. In the middle, the dark bit in the middle, what you can see, is the cast iron heat exchanger. Cast iron heat transfer is lower than that of the stainless steel or aluminium heat exchangers, making them less efficient. The hole you can see again with the copper file going through it, that's the thermostat. And the thermostat is connected to this electrical control box. So you can see the flue then goes off. This is a training sensor and this is the wrong flue system, but that's the single wall flue coming off there. It's actually flue ducting, which isn't allowed. Now this part you're seeing of the open fluid boiler is the back, and if we zoom in, this bit here is the draft diverter. So what would happen here, if we had downdraft from the flue, the air would come out this way and not affect the boiler itself. So the back you can see there, you can see the water connections. There's one water connection there, so that's the return. That's the flow pipe, okay, and that's the heat exchanger, that's the cast iron heat exchanger. So here is where we would do what's called flue flow test and spillage to see whether any products of combustion were coming back into the room. So So this is a full empty box, and I'll do a little drawing and try and explain this a little bit better. But this is where any downdraft would come in and wouldn't go in through to the boiler there to affect the back and the burner. Now let me try and explain how this draft diverter works with the aid of this drawing. Sorry about the crudity of the drawing, but hopefully you'll be able to understand this. So what we've got here is the open flue boiler. So we have the burner at the bottom, we've got the heat exchanger, we've got the hood, and we've got the flue, and the draft diverter is here. So this is open. This is not a sealed box, this is an open box here. So we get the primary air coming in, so this will be our primary air for combustion, would come in, and then the products of combustion would go through the heat exchanger, transferring the heat through the coil of the water coming through here. So this is snaky representing your water. So you return water coming in and then gradually going out and becoming hot. So return at the bottom, flow at the top. So the products of combustion then continue to go out and up through the flue. Got air coming in to help dilute the products of combustion. So we've got fresh air coming in, up and mixing in with the products of combustion, and then going up through the flue and then out through the terminal. If we get downdraft, so we get air coming back down here, so the downdraft is coming in, it will continue to come out here because we've got the least resistance, rather than going down and disturbing the flame here on the burner. It also, what it does as well is, if we've got excessive air coming in this way, it also stops the lifting of the flame. So basically, it's a draft diverter is a box. It's an open box to stop anything coming back down. Same kind of thing as what a catchment space would do at the back of a fire, or the draft diverter in the hood of a back boiler. It's deflecting the downward draft coming down the flue in adverse weather conditions. Hope that helps. Next appliance I want to talk about is a back boiler. A back boiler again is an open fluid appliance, and again an open fluid appliance gets its air from combustion within the room. So how does a back boiler work differently from the floor standing one? Well, basically this would be behind the fire. So this pipe you can see here, that would be attached to the fire. Again, this is the gas isolation valve. Remember, all gas appliances need them. And this is the gas valve itself. And this is the thermostat and the igniter. Again, this lead you can see coming off here and going to here. That is the boiler thermostat. This little tube you see coming off here and going into the hood, this is part of the ASD, the atmospheric sensor device. It's a safety device. Behind the bottom here is where you would see the pilot, and this is the burner. This part of it is all the heat exchanger, and then inside the hood you can see this part is the primary flue, this is the draft diverter here, and then the flue liner would come off the top in the chimney. Works a lot like the conventional boiler does, with all the same kind of controls, except this is more compact and would be hidden behind a fire. Quite low kilowatt ratings on it, but again your heat input 21 to 16 to 21 kilowatts. And that's that boiler. So the next boiler I want to look at is this little puppy here, and this is kind of the next step up from the open fluid boiler. So let's have a look. Now then, this boiler has all the same controls as the open fluid boiler and the back boiler. The only difference is This is what we call a room sealed boiler. Room sealed meaning it gets its air from combustion from outside rather than inside. So again, if we look at this boiler, again it's range rated. Yep, so you can see it's range rated. It's got the same controls, the same gas valve, the same igniter, the same type of burner. Okay, the only difference is now its air is coming from outside rather than inside. So we wouldn't have to do flow test and spillage on this boiler like we would have to do on a open fluid appliance. So this is a safer boiler and the next generation. So let's have a look at the Flue. 70% of UK homes are heated now by a combi boiler. Now this is the Flue system off that boiler. You can see it's a big square box on the back, and you can see there is two parts to it. So this front part here is where the products of combustion come out, and this part here is where the air goes in for combustion. Remember again, this is a training centre and this appliance isn't installed correctly. But that is a standard flue for what we call a balanced flue. Balanced flue meaning the air pressure going in is the same as the pressure going out. This is natural convection. In 1984, glowworm boilers produced the fuel saver. With its lightweight copper heat exchanger, it went on to be one of glowworm's best-selling boilers. Now then, this is the next progression in boilers. The boiler we've just looked at was balanced flue. This one is natural draft, but we've got a fan flue on this now. So we're now going the next stage up. Differences as well is this is actually a combi boiler, not a heat only boiler like the others. So the other boilers we've looked at would require cylinders. This wouldn't require a cylinder as it's a combi boiler which would heat hot water and heating. The Flue system now is completely different at the top. So instead of the big square box, now we've got a round flue. So let's have a look at this flue on the other side. The 1st of October in the UK is National Turn Your Central Heating On Day, where 90% of the UK turn on their central heating and the other 10% wish they had it to turn on. Now this is the flue on the other side of the wall. You can see now that this is where the products of combustion come out, and this is where the air goes in for combustion. Bit different from the big square box we had before. So this boiler we are looking at is the last of the atmospheric burners. So as you can see, this is an atmospheric burner, but there's a slight difference. This is what we called a band B boiler. So what we're looking at here now is a secondary heat exchanger. So this is where the return pipe would come back in to the boiler and then be heated by the flue temperatures exiting. So this boiler would exit its flue temperatures about 150 degrees, and this secondary heat exchanger would take that heat out and preheat the return water so the burner would have less work to do. So this is an atmospheric boiler, but this is what we call a band B boiler. Let's have a look at this secondary heat exchanger a bit more closely. So this is the secondary heat exchanger I've just been talking about. So what you can see here, this is where the fan off the top of the hood will be connected to. So this will be blowing the products of combustion through here. It would then exit here, out into the turret and then out through the flue. So this is how the products of combustion get in through here and out through there. The pipe you can see here, that's the pipe where the central heating return would come back in. So this is where the water would go. And then the pipe you see here, that's where the condensate would actually come out and go down to the trap. So this would be sat on the hood above the primary heat exchanger. So let's flip it around and have a look on the other side. The connection you can see here, this is where the secondary heat exchanger will be connected to the primary heat exchanger. So this is where the water would go then down into the primary where it's been preheated by the flue. Now I've taken the top off so you can see how this works. So the strips you can see here, this is where the products of combustion would be inside here, and the little holes is where the water would go through. So this is kind of the opposite way around, and the primary flue would be where the products of combustion would come through the little holes. So this aids it to take more heat out. So before it exits out through there, it then goes through this part of the heat exchanger. So the holes is where the water goes, the bars where the products of combustion are. So that's your Band B secondary heat exchanger. Now let's come right up to date. This boiler is still a room sealed boiler like the last one we've looked at. Same kind of flue system, slight differences in there, but this is what we call a condensing boiler. This is a high efficient condensing boiler, a boiler you can buy today. Now then, this is actually a system boiler, not a combi. The one we just seen was a combi boiler. That means it can heat up the hot water within the boiler through a plate-to-plate heat exchanger. This would require a cylinder like the first three boilers we've looked at. So this is a system boiler, but right up to date. Now this boiler we're looking at is what we call a heat only boiler. It's a condensing boiler, but a heat only. Unlike the system boiler we've just seen, it has no pump and it has no expansion vessel. They would all be installed externally from this boiler. So basically all it has is the gas valve, which is here, a fan, which is here, and the burner, which is here. Again, condensing, again up to date. Again, this boiler is, you can still buy this boiler, but this is a heat only boiler. Now the last boiler we're going to look at is this Ariston boiler. Again, this is a high efficient condensing boiler. The flue system is the same as all the others we've just been looking at, the last 2 or 3 we've looked at. But again, this is a combi boiler. So let's have a look at the parts on this boiler. So this is the pump. This is one of the energy rated pumps. Okay, so this is an ERP pump. Next to the pump is the gas valve. This is what we call a zero governor gas valve. This is the condensate trap. So this is a condensing boiler which produces condensate which collects in this trap. This trap is designed to stop smells and products of combustion coming into the room. This is the pressure relief valve, or the PRV. This is a safety device. If this boiler pressure goes over 3 bar, this would discharge to outside. At the back here where you see the arrows, this is the plate-to-plate heat exchanger. This is where the heat is transferred from the central heating water to heat the cold water coming in to give you hot water. This is the diverter valve, which is used to divert the water from the heating around the plate to plate. This tube now is going up to the fan, and the fan now sucks the gas in. This is a silencer to make it quiet. The fan sucks air and gas together, mixes it in this tube and sends it into the burner, which burns 360 degrees. This is Ariston's new burner. Okay, so that's what the inside of a combi boiler looks like today. Now you've just finished watching episode 5, part 1 of the history of central heating. Hope you've enjoyed the video. But if you want to watch any more of our videos, why don't you have a look at our YouTube channel? While you're there, why don't you subscribe? If you like this video, give us a thumbs up or put a constructive comment down in the comments below. If you ring that notification bell, we'll send you any notifications when our new videos go up on Wednesdays. So, hope you enjoyed this. Hope you enjoy the rest of our videos. Thanks for watching. Thanks for listening. Cheers.